We are not afraid to entrust the people with unpleasant facts, foreign ideas, alien philosophies, and competitive values.
And now for something completely different.
For a nation that is afraid to let its people judge the truth and falsehood in an open market, it is a nation that is afraid of its people.
Completely different.
According to a new study, the universe may stop expanding remarkably soon. According to recent research published in the journal Proceedings of the National Academy of Sciences, the universe may soon come to a halt after roughly 13.8 billion years of constant expansion, and then slowly begin to compress. Based on previous studies of cosmic expansion, 3 scientists seek to analyze the nature of dark energy, a mysterious component that appears to be forcing the universe to expand ever faster, in a new publication. Dark energy, according to the team's model, is a variable entity called quintessence that can decay over time. Even though the expansion of the universe has been speeding for billions of years, the repelling power of dark energy appears to be lessening, according to the researchers. According to their model, the universe's acceleration will come to an end in the next 65 million years, and then the universe will stop expanding altogether in the next 100 million years, ushering in a period of slow contraction that will end billions of years from now with the death, or perhaps the rebirth, of time and space. And this could all happen remarkably quickly, said study co-author Paul Steinhardt, director of the Princeton Center for Theoretical Science at Princeton University in New Jersey. Going back in time 65 million years, that's when the Chicxulub asteroid hit the Earth and eliminated the dinosaurs, Steinhardt explained. On a cosmic scale, 65 million years is remarkably short. According to Gary Hinshaw, a physics and astronomy professor at the University of British Columbia, who was not active in the study, says, nothing about this idea is problematic or impossible. However, because the model hinges on past observations of expansion alone, and because the present nature of dark energy in the universe is such a mystery, the predictions in this paper are currently impossible to test. For now, they can only remain theories. Since the 1990s, scientists have understood that the expansion of the universe is speeding up. The space between galaxies is widening faster now than it was billions of years ago. The unknown source of this acceleration has been dubbed dark energy, an invisible force that appears to work in opposition to gravity, pushing the universe's most massive objects farther apart, rather than drawing them together. Though dark energy makes up approximately 70% of the total mass energy of the universe, its properties remain a total mystery. A popular theory, introduced by Albert Einstein, is that dark energy is a cosmological constant, an unchanging form of energy that's woven into the fabric of space-time. If that's the case, and the force exerted by dark energy can never change, then the universe should continue expanding and accelerating forever. A competing theory, on the other hand, claims that dark energy does not have to be constant to reconcile with data of previous cosmic expansion. Rather, dark energy could be a dynamic field that changes through time known as quintessence. Unlike the cosmological constant, quintessence can be either repulsive or attractive, depending on the ratio of its kinetic and potential energy at a given time. Quintessence has been repulsive for 14 billion years. However, in comparison to radiation and matter, it contributed insignificantly to the expansion of the universe over the most of that time. That changed about 5 billion years, when quintessence became the dominant component, and its gravitational repulsion effect caused the expansion of the universe to speed up. The question we're raising in this paper is, does this acceleration have to last forever? Steinhardt said. And if not, what are the alternatives, and how soon could things change? In their study, Steinhardt and his colleagues, Anna Igers of New York University and Cosmin Andre of Princeton, predicted how the properties of quintessence could change over the next several billion years. To do this, the team created a physical model of quintessence, showing its repellent and attractive power over time, to fit with past observations of the universe's expansion. Once the team's model could reliably reproduce the universe's expansion history, they extended their predictions into the future. To their surprise, dark energy in their model can decay with time, Hinshaw said. Its strength can weaken. And if it does so, in a certain way, dark energy's anti-gravitational feature will gradually fade away, and it will revert to a state more like ordinary matter. According to the team's model, the repellent force of dark energy could be in the midst of a rapid decline that potentially began billions of years ago. In this scenario, the accelerated expansion of the universe is already slowing down today. Soon, maybe within 65 million years, that acceleration will come to a halt. Then, within 100 million years, dark energy will become attractive, forcing the entire universe to begin contracting. In other words, after nearly 14 billion years of growth, space could start to shrink. This would be a very special kind of contraction that we call slow contraction, Steinhardt said. Instead of expanding, space contracts very, very slowly. Initially, the contraction of the universe would be so slow that any hypothetical humans still alive on Earth wouldn't even notice a change, Steinhardt said. According to the team's model, it would take a few billion years of slow contraction for the universe to reach about half the size it is today. From there, one of two things could happen, Steinhardt said. Either the universe contracts until it collapses in on itself in a big crunch, ending space-time as we know it, or the universe contracts just enough to return to a state similar to its original conditions, resulting in another Big Bang, or a big bounce, spawning a new universe from the ashes of the old one. In that second scenario, which Steinhardt and another colleague described in a 2019 paper in the journal Physics Letters B, the universe follows a cyclical pattern of expansion and contraction, crunches and bounces, that constantly collapse and remake it. If that's true, then our current universe may not be the first or only universe, but just the latest in an infinite series of universes that have expanded and contracted before ours, Steinhardt said. And it all hinges on the changeable nature of dark energy. How plausible is all this? Hinshaw said, the new paper's interpretation of quintessence is a perfectly reasonable supposition for what the dark energy is. Because all of our observations of cosmic expansion come from objects that are millions to billions of light years away from Earth, current data can only inform scientists about the universe's past, not its present or future, he added. So, the universe could very well be barreling toward a crunch, and we'd have no way of knowing until long after the contraction phase began. I think it really just boils down to how compelling do you find this theory to be, and more importantly, how testable do you find it to be, Hinshaw added. Unfortunately, there is no good way to test whether quintessence is real, or whether cosmic expansion has started to slow, Steinhardt admitted. For now, it's just a matter of fitting the theory with past observations, and the authors do that perfectly in their new paper. Whether a future of endless growth, or rapid decay awaits our universe, only time will tell.
reality is merely an illusion. What remains is the raw, shocking, humiliating truth at the bottom.
And now for something completely different.
The truth is out there. Never stop searching.
Completely different.
Follow us on
Proceed to exit.
Facebook, Twitter, YouTube. If it's not the raw news, it is just news.
Completely different.
Subscribe today because I like it raw.